Bismillahirrahmanirrahim. Hello everyone, I hope you are all doing well. I welcome you all in class of real analysis by Robert G. Bartle. In last lecture, we have discussed about the absolute value of a real number. In today's lecture, we will discuss the proof of theorem 2.2.2, corollary 2.2.3, triangle proof of triangle inequality, and the proof of most generalized form of triangle inequality. So this is a very important lecture. In last lecture, we discussed about the absolute value of real number. Let's just revise the definition. The absolute value of a is denoted by this notation, and it can be defined as this is equal to 0 if a is 0. In case if a is non-zero, that is if a is greater than 0, then absolute value of a is equal to plus a, and if a is negative, then absolute value of a is minus a. In this theorem, actually this theorem, or you can say the lecture is actually about the properties of absolute value of real number. In this theorem, the first part is we have to show the absolute value of AB is equal to absolute of A into absolute of B. In other words, you can say that the absolute value of product of two number is equal to product of their absolute. The square of absolute is simply equal to square of that real number. If C is any non-negative number, then absolute of A is always less than or equal to C if and only if minus C less than or equal to A less than or equal to plus C. The last one is also important. For any real number A lies between these two numbers, minus A absolute and plus A absolute. So let us discuss each part one by one. In the first part, we have to show the absolute of AB is equal to absolute of A into absolute of B. So here there are the two possibilities. It is possible that your A and B both are, or one of them is 0, or it may be they are non-zero. This is the first case. If either A or B, one of them is 0, then both of the sides are equal to 0. Suppose if your A is 0, then your left hand side becomes 0 into B, and your right hand side becomes 0 into B absolute. So in this case, 0 into B, this is 0, and this is also equal to the absolute value of 0 is 0, 0 into B absolute. B absolute into 0, this is equal to 0, and 0 absolute is equal to 0. So both sides are equal to 0. Next we discuss these four cases. In these cases, both A and B are non-zero. The first case, if A and B both are positive. In this case, as A is positive, so the absolute value of A will be equal to plus A. Similarly, as B is also positive, so the absolute value of B is equal to B. As A and B both are positive, so their product is also positive. It means the absolute value of product AB is also equal to positive AB. So we can write absolute value of AB, which is equal to A into B, as A is equal to A absolute here and B is equal to B absolute. So this shows AB absolute is equal to absolute of A into absolute of B. Case number 2. If A is positive and B is negative. In this case, A is positive, so its absolute value is equal to A, and absolute value of B is equal to minus B. As A and B have a opposite sign, so their product will be negative here. As the product is negative, so the absolute value of AB will be equal to minus AB. This is minus AB. So we can write absolute value of AB, which is equal to minus AB, as A into minus B. This is minus B. As minus B is equal to, as minus B is the value of B absolute here, so I can replace minus B with B absolute. and A with A absolute. Again, we have the same result. Third case, if A is negative and B is positive. In this case, as A is negative, so absolute value of A is minus A and absolute value of B is equal to plus B. Again, when A and B have an opposite sign, their product will be negative. In this case, the absolute value of A is equal to minus AB. So we can write AB absolute is equal to minus AB. That can also written as minus A into B. As minus A is the absolute value of A, so we can replace minus A with A absolute and B with B absolute. Again, we have the same result. Last case. If both are negative, then A absolute is equal to minus A and B absolute is equal to minus B. As A and B both are negative, but in this case their product will be positive. So the absolute value of AB, because it is positive, is equal to positive AB. So we can write AB is equal to absolute value of AB is equal to AB. That can be written as minus A into minus B. As minus A is the absolute value of A here, so minus A can be replaced with this number and minus B can be replaced with B absolute. Again, we have the same result. Further, you can summarize both of the these four cases into two cases. Case number one, when A and B both have same sign, same sign. And the other case, case number two, when A and B have the different sign. So rather than discussing these four cases, you can discuss just these two cases. These are different cases. Next we have to show that the square of absolute is equal to A square for any real number A. For any real number A, the square of A is always greater than or equal to 0, that is negative. The square of any real number can never be negative. So A square is always greater than or equal to 0. Now A square is, if A square is always greater than or equal to 0, it means the absolute value of A square will be positive A square. So I can write A square is equal to absolute of A square. These are, again I am writing this. Further, I can split A square as A into A. Now for this step, we can use the above property AB absolute is equal to A absolute into B absolute. So by separating this absolute into a product of two absolutes, and further this can be written as square of A absolute, which is required. C part. If C is greater than or equal to 0, then A absolute is less than or equal to C if and only if minus C less than or equal to A less than or equal to C. For example, if your A is less than or equal to like 7, you can expand this as minus 7 less than or equal to A less than or equal to plus 7. Firstly we suppose that A absolute is less than or equal to C. We show A lies between minus C and plus C. As A absolute is less than or equal to C, then we have both A is less than C and minus A is less than equal to C. How can we obtain these two inequalities? As here A absolute is less than or equal to C. This depends on value of A. If A is greater than 0, then your A absolute is simply equal to A. So in this case, if A is positive, then A absolute is equal to A. So we have first inequality A less than or equal to C. If your A is negative, then your absolute A is equal to minus A. In this case, again we have inequality minus a less than or equal to c. So from this inequality, we have these two inequality, a less than or equal to c and minus a less than or equal to c. Say this is my inequality number 1. I further can write this inequality as minus a less than or equal to c can be written as multiply on both sides with minus sign. When we multiply this inequality with minus sign, this becomes a greater than equal to minus c. Now when we multiply an inequality with a negative, uh, then the sign of inequality becomes changed. So this becomes a greater than equal to minus c. In other words, you can write minus c less than or equal to a. Say this is inequality number 2. Now combining 1 and 2. Uh, into minus c is less than or equal to a, and further a is less than or equal to c. Hence we have minus c less than or equal to a less than or equal to c. That is required. Conversely, we suppose that minus c is less than or equal to a less than or equal to c. Again, from this inequality, I have two inequalities. I have two inequality. First is minus c less than or equal to a from the first part of this inequality, or this can be written as by multiply minus on both sides we have minus a less than or equal to c. Say this is inequality number 3. And from this part, second part of this inequality, I have inequality a less than or equal to c. This is inequality number 4. Combining 3 and 4. In 3, minus a is less than or equal to c. In 4, a is less than or equal to c. So when you will combine, both are the values of a absolute. So this becomes a absolute less than or equal to c here. D part. This is also very interesting. For any real number a, it lies between minus a absolute and plus a absolute. This is very interesting. To prove, just take c is equal to a absolute in part number c to get the required result. In part c, we have shown that a absolute less than or equal to c implies minus c less than equal to a and a less than equal to plus c. If you just take here c is equal to a absolute, we have minus a absolute less than or equal to a less than equal to a absolute, which is required form. So this completes the first theorem. Next we prove triangle inequality 2.2.3. If a and b are any two real number, then the triangle inequality says that the absolute of a plus b is always less than or equal to a absolute plus b absolute. There are many proof of triangle inequality, but this is one of the best proof, and this is very shortest way to prove this inequality. I am using the D part of above theorem 2.2.2. In above theorem D part here. Here we have shown that for any real number a, its values lies between minus a and plus a absolute. So by using this theorem, I can write a lies between these two values. Similarly, b lies between these two values. Next, just by adding these two inequalities, we will add each of the respective part. The first part is minus a absolute, and here the first part is minus b absolute. When you add them, this becomes minus a absolute minus b absolute. Taking minus as the common, we have minus a absolute plus b absolute. Next, adding the second part of both inequality, this becomes a plus b absolute. And lastly, adding the third part of both inequality, this becomes a absolute plus b absolute. Hence, by 2.2.c, what was 2.2.c? This is 2.2.c. So, according to 2.2.c, this can be written as 2.2.c says if minus c less than equal to a less than equal to c, then a absolute is always less than or equal to c. Now, according to this result, our a is this. This is my a. This is my c, and this is my minus c. So, when you apply this result, we have the required triangle inequality. The next one. Next one is a very important fact. In triangle inequality, you can see there is an equal sign here. There is an equal sign here. Can you tell me in which case this triangle inequality has equal sign? Uh, Suppose I say when A and B both are equal, when A and B both are equal to 0, I say A and B both have same sign, same sign. Fourth, they have opposite sign. So this is my question. What do you say? When the equality hold in triangle inequality? This is very important fact. The answer is, it can be shown that the equality occurs in the triangle inequality if and only if A and the product of AB is positive. In other words, which is equivalent to saying that A and B have the same sign. This is the important fact. In triangle inequality, equality sign hold only when A and B have a same sign. Although equality will hold if A and B both are equal, but the most accurate answer is when they have a okay. Next, we discuss some useful variations of triangle inequalities. This is corollary 2.2.4, and this is very important. In this corollary, we have to show the absolute value of A absolute minus B absolute. This is always less than equal to absolute of A minus B. And in the B part, we have to show absolute of A minus B. This is always less than equal to A absolute plus B absolute. So actually, to prove these inequalities, we will use triangle inequality. So in order to prove A part, uh, if you expand this inequality, you can see we have to show this can be written as minus absolute value of A minus B. This is less than equal to A absolute minus B absolute, and this is less than equal to A minus B. You can expand this by using this fact. A absolute less than equal to C implies minus C less than or equal to A less than or equal to C. So to form this inequality, firstly, we can write A is equal to A minus B plus B by adding and subtracting B. Now taking absolute, we have A absolute is equal to A minus B plus B absolute. Next, by using the triangle inequality, the triangle inequality can break the sum of these two numbers as a sum of two absolute. This is my first number, so this is the absolute value of first number, plus this is my second number, this is the value of absolute value of second number. Subtracting B absolute on both sides, we have A absolute minus B absolute less than or equal to A minus B. So this is the actually, this is the second part that we have proved here. Next, similarly, now we write B absolute is equal to B minus A plus A by subtracting and adding A. Again, by using the triangle inequality, this is my first number and this is my second number. So it can be break as absolute of first number plus absolute of second number. By shifting B minus absolute on other side and also subtracting B absolute from both sides, this becomes A absolute minus B absolute is greater than equal to minus times B minus A absolute. As you know, the absolute value of A minus B and B minus A both are equal. So replacing B minus A with A minus B. So this becomes minus times A minus B absolute less than or equal to A absolute minus B absolute. Say this is my inequality number 2. Combining 1 and 2. In 2 we have this part and in 1 we have a absolute minus b absolute. This is less than equal to a minus b absolute. This is my inequality number 1. Okay, next, by using theorem number 2.2.c, what was theorem 2.2.c? A absolute less than or equal to c can be written as minus c less than or equal to a less than or equal to c. So here we have this form that can be enclosed in this. So this becomes, this is my c, central number is my a, this is my c, and this is my minus c. So by using this fact, you can enclose this central number as in absolute values, which is less than equal to absolute of a minus b. In b part, we have to show absolute of a minus b. This is less than equal to sum of two absolutes. As a triangle inequalities, what is triangle inequality? A plus b absolute is less than or equal to a absolute plus b absolute. Just replace b is equal to minus b in this inequality. So we have a plus minus b and a absolute plus minus b absolute. This can be written as a minus b, and minus b absolute is equal to b plus b absolute, because absolute of minus b and absolute of plus b both are same. So we can replace minus b with b plus absolute, which is required form. In the last result, we will prove corollary 2.2.5. Actually, this is the most generalized form of triangle inequality. You can generalize triangle inequality for any finite number of real numbers. This is just not hold for only two real numbers. If we have n real number, a1, a2, a3 up to so on an, these are the n any real numbers, then absolute of their sum is always less than equal to sum of their absolute. Or in summation form, you can write it as I is equal to 1 to n summation ai absolute less than equal to summation of ai absolute. To prove this inequality, I will use mathematical induction. For n is equal to 1, when you put n is equal to 1 here, we will take only one value. This from the left side, this is a1 absolute, and from the right side, this is also equal to a1 absolute. So in n is equal to 1, this is just a1 absolute is equal to a1 absolute. If you take n is equal to 2, then absolute of a1 plus a2, this is always less than equal to a1 absolute plus a2 absolute. This is hold by definition of triangle inequality. Suppose that the statement is true for n is equal to k, that is sum of k real number, absolute of sum of k real number is less than or equal to sum of their absolute values. Say this is my star. Next, we show that the statement is also true for n is equal to k plus 1. So in this case, I have to show the sum of absolute of sum of k plus 1 values should be less than or equal to sum of absolute of k values. I can consider k plus 1 values as this sum of k, first k values. This is my first number. As you know, a1, a2, a up to so on ak, these are all real numbers. So sum of these k real number is also a real number. Suppose this is my b and this is my a. So I can use a triangle inequality for these two real number. This can be separated as a sum of two numbers. This is absolute of b and this is absolute of a. Next, by using star says that this absolute is less than or equal to sum of these absolute. What is my star? This is my star. Sum absolute of sum is less than or equal to sum of these absolute. So by using star, I can replace this absolute as. Now this is the sum of k plus 1. This is sum of absolute of k plus 1 values. that is required. And in a summation form, this can be written as absolute of k plus 1 real number is less than or equal to sum of absolute of k plus 1 real number. Statement is true for n is equal to k plus 1 whenever it is true for n is equal to k. Hence, this statement is true for any natural number. So, in today's lecture, we have discussed so many things. I hope you have a now clear understanding of all of these. Still, if you have any question, you freely ask me. You comments me, inshallah, I will reply you. If you find this lecture is helpful, kindly like, share, and subscribe my channel. See you in the next lecture. Take care. Allah Hafiz.